Alright, this is practice problem 4.9. Write the balanced molecular and net ionic equation for the following neutralization reaction, which is aqueous acetic acid is neutralized by aqueous barium hydroxide. Alright, so we know a neutralization reaction, you're going to produce a salt plus water. Okay? And so for this equation, right, we know that the salt is just going to be the cation of the base and the anion of the acid. Alright, and so we have CH3COOH, okay, and we're reacting that with barium hydroxide. Alright, and so if we combine that, okay, we have CH3COO minus, okay, plus we're going to have barium, Ba2 plus, okay. And so we combine those, and basically we get barium acetate, okay, which is CH3COO, and it's going to be 2 of those. Alright, and so this is soluble. Alright, so the first thing we want to do is write the balanced chemical equation, okay, and if you balance it, you end up getting 2CH3COOH plus BaOH2. Okay, this is aqueous, and what we're going to form is the salt plus water, and so we get BaCH3COO2 plus 2H2O. Okay, and the water is going to be a liquid. This is aqueous as well. Alright, so we can identify the strong electrolytes at this point. Right, the first thing we can do is we have a weak acid for acetic acid. We have an ionic compound for barium hydroxide. We have a strong base for barium acetate. And we have a non-electrolyte for water. So if we write out what these ionize as, okay, we're going to end up with 2CH3COOH, which is aqueous, plus we're going to have barium, which is going to barium hydroxide, which is going to ionize, so Ba2 plus we have 2OH minus. Okay, both of those are aqueous. We then have the strong base, barium acetate, which is going to ionize as well. So we end up with Ba2 plus CH3COO minus, and we have 2 of those, plus we have 2 H2Os, which will not ionize. Alright, and so then the last thing we need to do is to write that net ionic equation. We need to cancel what's on both sides, which is going to be the barium. And so at that point, we're going to end up with 2CH3COOH plus 2 hydroxide ions is going to give us 2CH3COOH, or I'm sorry, CH3 minus, plus we have 2H2O. Alright, and so the one thing you can note here is that these all have a 2, and so we can actually just reduce all those, and so you can remove that for your final answer.